Welcome to a new test and teardown video. This time it's another Hewlett Packard. This one is the 8642A signal generator from 0.1 to 1050 megahertz. As you can see here, it is in near new condition. It is really beautiful. All I did was I gave it a tiny little brush and then it looks like this. How about that? I only found a little bit of scratches here on the right side, and that is because people always place this on its right side here. And that's actually because there's only one handle in the left side. And as you can see from this yellow marker here, 2-person lift. This thing, I just put it on my scale, and my scale says 32.7 kilograms. Wow. And what do you know? I found the manual from 1985, and it says 32.7 kilograms. Isn't that lovely? So yes, it's just a super nice one. I really look forward to play with this one. Unfortunately, there is a power supply failure, so there's no live, no action of anything here. So the first thing is I need to go inside and see what I can do with the power supply. So now we're inside. Inside the lid is a very good explainer about a lot of things, actually. So if we see here, we got a lot of completely sealed modules. The first 3, they're actually mounted in a rubber kind of suspension system here. I don't know if you can see this. See? You can even see it here. See? Flippity floppity. So that is of course to avoid mechanical vibrations from the mains transformer into critical parts. And inside that one, the A9 module is the optional high stability oscillator, if I'm not mistaken. And also this the manual here, or this here, says something about how to read the coax cable color codes, and that is really smart. So you got the background color and the lowest digit first, and then the highest digit last. So it's that easy. So if you just look real fast here, 1 2 3 4, that one, right? See, the background here is 9, and then 2 3. It's that easy. So if this is that module here, right? So this is J1. So all we have to do is go for that module here, and then we'll look for that was the A11, right? And J1 is 9 2 3. So now you know exactly what connector goes into that position. And that is super important when you pull this apart, because if you want to perform service on one of the modules and you want to assemble it correctly again, I always take careful pictures and notes and all that. I even write with permanent markers on my cables and all my stuff, because I really don't want to screw something up. Oh, here's a little access cable for something. I'm doing my little inspection round first, just to see what is the health state of this unit. But I do see something that worries me a little bit. I don't know if you can see this little white. Yes, you can. That is humidity that infected the aluminium. That is not good. And that causes all sorts of conductive dust that can actually cause a lot of problems. And then you will see here in the corner, look at that. Oh, there's a lot. This is really, really bad. I don't want that to go down there. It's super, super packed. And now you understand where the 32 kilograms are coming from. So of course I need to go and have a look at the power supply. It has to be that big bad boy in here. And here is the mains entry. So while I'm inspecting and cleaning it up a little bit, it was actually easy to clean up a little bit of this rust here from the corners. I of course wanted to inspect the CPU module, and that is the first one, because there is a battery here. I think this is a rechargeable nickel cadmium, right? So that one we'll have to inspect as well. And yeah, it is a 68,000 CPU. It's running 5 megahertz, so it's a 16-bit CPU. That was high tech in 1985, I'm telling you. And this CPU actually, it is the 16 bits bus is actually what's going around to all the other cards that's doing memory and interface and stuff like that. So they really went all the way with this one, and the CPU accessed 250 kilobytes in total in this entire unit. So I'm actually a little bit impressed. You probably remember the home computer Amiga that was also using the 68,000 CPU. Maybe I found some of the problems. See, there is actually a wire with one of those connectors here, right? So this one can be connected to 1, 2, 3 different places. Now is the question, where? And then there is the NTC is broken. It's probably going to be that point right there, right? It was probably soldered right there, so that is definitely a good place to start. And then the colors here, are they correct or not? That is the big question for today. I would definitely start with that. What a big beast to work around with here. So I'm taking out the sides as well. Remember, I found some corrosion in this area. You can even see it's in here as well. See, this is the inside of that panel. That was there, right? So this is not so good. And here's of course the power supply. Beautiful implementation of thermal. I mean, isn't that nice? So air can go through and heat can spread to the entire frame. I mean, this is good thermal design. I like it. But this is of course the side, and it's been standing on that side because this is the no handle side. Look at that. Green corrosion here on copper as well. That tells me that we got some leaked capacitors or some acid or some other kind of damage that's kind of going out here. And if we look on the other side, yeah, we got some big bad boys here. You see this sticky, slimy, black all over the place here. That is on the back side of this power supply cover. This is sticky, grossy. But we got a little bit of info here. So far I'm not able to find a schematic of this power supply, but I'm not giving up completely. But at least we got something about the voltages. Ooh, 50 volts, huh? And then plus minus 15. We got 5 volt, positive and negative. I mean, maybe those are all the voltages we are talking about. I would like a little bit more information here, but at least I can measure on the top of those fuses. Or are they on the front or on the back of the regulator? Is that a test point for the voltages? It's a little bit annoying. I really feel that I can't get started before I find some more documentation, but at least I'm trying to dig my way down to the power supply. I don't know exactly what to say, but I try to talk nice while on the video. Well, this is why it was difficult to take away the bottom cover. Oh my god, this, you know, this foam, they use it for thermal and for stability. You don't want to have this back plate going and readily rattle, but really, is this necessary? I don't think so. And this turns itself into chewing gum and stuff, and it's sticky, smelly, and look at that. It's just absolutely turned itself into poo. So I have to remove it carefully because it's very, very sticky, and and my fingers, they go to slimy, sticky. But at least, nasty. So that is the bottom side of the power supply, but I don't really see anything fancy smancy here. Just some capacitors, probably some connectors here. A big, good star point for ground, so that is good to chassis. So far, so good. But where's all the regulation, controlling, and handling all the transistors and stuff? I don't really see a lot so far. So, oh yeah, you're gonna love this, by the way. What I found here on the back, there was a metal cover here, and then there's a nice little module and a little test connector. So that one, you can remove this little module and you can plug this into your CPU card. And as you can see here, it consists of 2 one-time programmable EEPROMs without a window. So that is a test program. Isn't that cute? And of course, test calibration software is here. So when you plug this in, the CPU will boot this special software and run all the programming and calibration stuff. And of course, you want to access some measurement points, and you can do that with this easy interface here. So that is SMB to SMA if you don't have one of these. So that's pretty cute. It's actually very well documented in the manual, page 302, I think it is. Have a look here. It even says A, B, C, and so on, right? So that is the orange wire, also called number 3. And see, the missing wire is white and gray, so that is 9, 8. So that goes here. It's that easy. All you have to do is look in the manual. But what I hear is this module let out some smoke signals. So I think there is a little filter in here, and that is definitely broken. But to access the mains transformer, I want to remove everything here and just input the correct voltage into the correct wires, and then see what is going on. As far as I hear, maybe the rectifier stuff is working, but I am missing some voltages. And on the top of the power supply board, this is the power supply board, the whole side here, and there should be some status LEDs, and that will tell us what kind of voltages we are missing. But we're missing voltages here, so I want to, of course, trace that everything is good on the A18 board. That is the rectifier and capacitor board. So that's the way I want to do it. I just want to confirm that everything is nice and smooth everywhere, because then I can rotate this one and be happy. So here's how I plan to connect it directly to the transformer. So that is 04 and 05. They're connected together and carefully isolated. The orange is number 3, so that is not used. And 0 and 02. That will be my 240 volt input. So I think I should be able to proceed now. I'll just secure this a little bit and then let's see what happens. So now we are more or less, I don't know what we are, a little bit into powering this on. Mains transformer uses about 6 watts in idle. So we're running at mains input. And if I crank on the power switch, we hear the powerful fan go berserk. And as you can see here, this is the A17 module, the power supply. It's a very complicated power supply, or like quite complex, full of a million things. But what we see here, let's turn this off again. We see only 3 green LEDs, and that is because if we look at this nice little explainer here, we don't have plus 5 volts and we don't have plus 15. Those 2 are missing, and that is what I need to trace down. Just to make it real easy for you guys to navigate around in. So this is the bottom, or the first part of the power supply. This is the A18 board, and we of course see it from the bottom side where it's super easy to access everything. And that will be the different capacitors and the different voltages and all the fuses. So this is what you want to check out. And in this case, all my voltages, they are there. They're quite accurate, and all my fuses are okay. All the voltages go straight through the fuses. So I'm super happy about that. That means I don't need to worry anymore about the A18, and now I can focus on A17, the real challenge. So look at this. This is the power on sequence of 5 volt. We got almost 6 volt. And I believe the 5 volt regulator should give 5 volt, right? So this is almost 6 volts. And we got 2 nasty spikes here. I don't know exactly what they are doing, but the last of that spike actually triggers a over voltage protection and shutdown system in the 5 volt. And they're all made exactly the same. So here's the schematic of the positive 5 volt regulator that is not working, and I was measuring on the top of Q8, that is the collector, that's also the output, and of course Q10 here is triggered by this Zener and by the spikes, so that is definitely not so good. So what I want to do is I want to trim down the voltage and then see if this stops. So now the 5 volt is actually coming after I've been measuring on the reference resistors. For some funky reason 5 volt is running. So now 15 volts is having a fun power on sequence. And so it goes to 15, and then after 100 milliseconds it goes like this. So this is obviously overcurrent, and you can see all this ripple. That's probably because the voltage is not into regulation or overloading. I'm so sorry for all the fan noise here, but as you can see, all the voltages are nice and fine. And after measuring around here and measuring the currents and voltages and all that kind of stuff, it is actually quite clear that it's a overconsumption kind of problem. So what I've done is I disconnected all the communication and power cables, all those flat cables that goes to all the modules, and now my consumption is very low, and this is also of course why all my voltages, they're fine. So there's one of the modules here that's using way too much. The problem is, well, let me crank this off. The problem is the current don't really heat up the cables here. I tried that with my thermal camera to see if I could see which one of the modules had warmer cables here, because those are quite thin. But I think a lot of the wires here, they're in parallel, so there isn't really any detectable heat up in any of the cables. So that sucks a little bit. So now I really am back to the needle in the haystack kind of problem. Going to believe what I did. I measured all the different modules one by one, and look at that. So first I took the 6-watt idle from the mains transformer, and then I turned it on, only with the fan, CPU and the front board in it, and that is 60 watts. And then I plugged in one module by one, only one at a time, right? And then noted what is now my total power consumption, and then I subtracted 60 watts. So now this is the power usage per module, right? And then I added everything together, and it is 172.1 watts. So now I plugged in everything at the same time, powered it up, and look at that. The total is 173. How is that possible? So I think it actually works now. Let's look at the front. It's saying some stuff here. Oh, it's about 10 megahertz, blah blah blah. Maybe I can hit the preset. Instrument preset. Oh, so there's a I need to input the megahertz, right? So that is really funny. While I was testing all the individual modules one by one, the power supply had, of course, plenty of power to remove the short or the component that was using too much power, and I didn't have any indication about what module it is, so that is a little bit funny. I think it's just a capacitor or something like that that was using way too much power, but that problem is kind of blown away or cut away or something like that. So now the unit actually works. Oh, that is so funny. And the thing is, going into all the individual modules, that will take me a week to go through them, and they're like full of all sorts of, you can probably see there's a top and a bottom part and all the screws to pull them apart and all those, and interconnects and cables in between here, and oh my goodness. So I'm actually quite happy not to not to do that. All right, so here's my 6-watt idle. Let's just crank on the power and turn off the light here. It is a really oh, let me do like this. It is a really big, bright, sharp and nice display. It's super easy to read, and it's doing, isn't that nice, still checking. And that is the version 3.2, and then it blinks because it wants me to read the messages. So all you have to do is read the test, blah blah blah, failed, and it's of course because end of messages. Good. So we can go to frequency 100 megahertz, amplitude 0 dBm, and then we go like this on the scope, and here's a 102 megahertz. And that is of course because everything is out of alignment, and this, I don't think this one is the high stability oven, otherwise we wouldn't see that, but I really think it works. And we can do AM and then on. Yeah, look at that. That's AM on off. We can do FM on. Oh, of course not in 10 megahertz or 100 megahertz mode. So let's just go to frequency 10 megahertz, and then we already got some frequency modulation on. So let's crank on some more FM. Yep. So you can do a lot of funky FM modulation at the same time. Haha. It's down to 168 watts of power consumption. Let's do it like this, so the instrument is nicely upside down here on the video. It's a beautiful signal generator, but holy camole, it is really, really full of electronics, and that fan is driving me insane. So yeah, I think we are back alive. It could be a little bit interesting to see if the initial problem is still in this one. So I think I'll take my Mega and see if there's a short inside one of the filter capacitors here. So that is interesting to try and do that. So I tried all the different combinations here with my good old Mega here. And I think this is only doing 1000 volts, but there isn't any problems at all. This filter handles all the voltage, and there is connectivity and isolation and all that kind of stuff. So I just want to go and assemble this. I also changed my input voltage to 240. This is a really funny voltage selector. You pull out this little PCB and then you rotate it and stick it in again. That's quite funny. You can probably find this part somewhere if you're really smart. But I'm quite lucky that there's no problems with that one. By the way, a little trick. The glass here was completely loose all the way. So see, I took my soldering iron and just made two little dots here in the black plastic. You can't see this because it's sitting like this, right? See? Now it goes a little bit like that. And it's not gonna go any being annoying. Yeah. So now I'm done, reassembled, everything is nice and fine, and it powers up and all that kind of stuff, as you can see here. So thank you very much for watching. I hope you had a little bit of fun.